a curve called a strophoid, and we want to know where this strophoid has horizontal tangents. So if I take a look at the graph here, somewhere around here I have a horizontal tangent, and somewhere around here I have a horizontal tangent. So to find a horizontal tangent, I need a derivative. So that's the first thing I'm going to do, is I'm going to differentiate this expression. So differentiating this expression implicitly, I end up with 3x squared plus 8x plus, this is going to be a product, so I have to use product rule. So it's going to be 1 times y squared plus x times 2y. I have to apply the chain rule here, times y prime. And then minus 8y, and again I have to apply chain rule, so times y prime, and that's equal to 0. So then I'm going to group together my terms here. So I'm going to group together my y prime terms. Okay, and I'm going to then solve for y prime. So grouping together my y prime terms, I'm going to do that, and I'm going to factor. So I'm going to be left with 2xy minus 8y, and then all the other terms are going to move to the other side. So negative 3x squared minus 8x minus y squared. Solving for y prime, we get negative 3x squared minus 8x minus y squared, all divided by, and I'm going to factor out the common factor of 2y, and I'm left with x minus 4. Okay, so I have a divisor here, so I need to make sure I state my restrictions. Y is not equal to 0, x is not equal to 4. Okay, and then I'm looking for where the derivative is equal to 0, so then I make this equal to 0, and there's my equation which I want to solve for. The problem with this equation, though, is we have two variables. If I have two variables, I need two relationships to be able to solve it as a system. So I need to find some other relationship. And where I find that other relationship is actually in the original equation. So this is a relationship that relates x to y. Well, that's what I'm looking for, so that can be used for my system of equations. And in general, this is a nice thing about differentiation, is that as we differentiate, as long as we have information about the derivatives or the second derivatives, we can continue to differentiate and generate other relationships of x and y. So if I have information about the second derivative, I can differentiate again and find the second derivative, and then use that second derivative as another relationship to be able to solve a system of equations. So there's my other equation. It looks like that's going to be easier to solve for y than for the x. So I'm going to isolate the y squared. So I'm going to first factor out, I'll rewrite this. I'm going to first factor out the y squared. I end up with x minus 4 equals 0. Solving for the y squared, I end up with negative x cubed minus 4x squared all over x minus 4. Okay, so I need to then square root this if I'm going to solve for y, but in this problem here, since it's equal to 0, I really don't need to solve for the denominator. Okay, because if I were to actually solve this equation, I would cross multiply, and this is going to just multiply by 0 and disappear anyways. I do have to observe my restrictions, and I do have to be careful of this, because if x is 0 here, that would make y equal to 0. So there is that restriction already exists. So I need to include that x not equal to 0 restriction, so that I observe this part here. So once I have that, I'm going to just look at the numerator and rewrite my equation like this. Negative 3x squared minus 8x minus y squared is equal to 0. And I'm going to replace this y squared with this blue y squared. So I end up with negative 3x squared minus 8x minus, and then in here it's going to be negative x cubed minus 4x squared all over x minus 4. Okay, so I have to be kind of careful. In fact, you know what? there's a bunch of negatives in here, so I think I might just simplify things a little bit here. So I'm going to factor out that negative, and that way I don't have to deal with the negatives, because if the negative is equal to 0, then the positive is equal to 0. So then it might be a little bit easier then. That way I don't have to keep track of a whole bunch of negatives. I'm going to now substitute in plus negative x cubed minus 4x squared over x minus 4. And that's equal to 0. Okay, so I want to get rid of this divide by x minus 4. I have already observed my restriction for that. So times x minus 4. And I'm going to end up with 3x cubed plus 8x squared minus 12x squared minus 32x minus x cubed minus 4x squared equal to 0. Combine my like terms. I'm going to end up with x squared, negative 4x squared, negative 8x squared minus 32x equals 0. Factor. There's one solution. Okay, so then I have a quadratic solution here. X equals 0 is a solution, but this is extraneous. Solving for this x, I'm going to use a quadratic formula. X is equal to negative of negative 4 plus minus square root of negative 4 squared minus 4 times 1, or a times c. And that's all over 2a. This works out to be 4 plus minus square root of 64 positive. This is 80 over 2. We can simplify this into 2 plus minus square root of, looks like 20. 2 plus minus square root 20. Okay, and then this works out to be 2 plus minus 2 root 5. Okay, so if we take a look at the graph, 2 plus 2 root 5 is going to be outside of our domain. So we're just going to use the x equals 2 minus 2 root 5, and that's going to be the position right about here. So this position here is going to be 2 minus 2 root 5 approximately. So then we need to find those two y coordinates. Well, we can find those two y coordinates by substituting back into my system of equations. So there's my solution. I'm going to plug it back into there. And so I end up with y squared is equal to negative, I'm just going to factor the negative out, it's going to be x cubed. So x was 2 minus 2 root 5 cubed minus 4 times 2 minus 2 root 5 squared, and that's all over 2 minus 2 root 5 minus 4 in the denominator. Y squared, plugging that all into calculators, we can simplify the algebra of that, but let's just plug this into the calculator, and we're going to end up with, looks like 1.44 approximately. So y works out to be approximately 1.20 plus minus. Okay, and then so if we take a look back at our graph, then this coordinate here is going to be y equals plus 1.20, and this is going to be negative 1.20 right about there. Okay, so those are the equations, or the locations of those tangent lines. So at x equals 2 minus 2 root 5, y equals negative 1.2, and y equals positive 1.2. The exact values are here, so if you want to go through all the algebra, you can, this value here should be equal to that same value.